Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Hello, welcome to another episode of the Distributed Data Show. I'm Jeff Carpenter, and I'm live here in the studio, and with me via the interwebs is Nick Panahi. How are you doing, Nick?
Hello, everybody. Hello, Jeff. Thank you for having me.
Yeah.
Very excited to be here.
Nick is the product manager for DSE Search, our DataStax Enterprise Search. So he is the master of all things search and probably the best hair we've ever had on the Distributed Data Show. It might not even be a contest at this point, but we'll have to work on that. So I jest. We want to talk with you about all things search, Nick. So we had a previous episode in which we really dove into secondary indexes and the good, the bad, the ugly. And I know that you're familiar with what we talked about there. But let's kind of pick up where that last conversation left off. What are some of the limitations of secondary indexes?
That's a great segue, Jeff. Thank you for that. And let me explain why that's a great segue. Is for DSE Search and other search technologies that integrate with Cassandra in general, the secondary index path is a very common hook, as we call it, to integrate. And there's a lot of details there as to why that is. I won't get into the depths, but let's just say the inverted index is a common thing between Cassandra's secondary index and text search. So that's why it's a great segue, as far as I'm starting there. And getting back to the original question, the limitations, well, of course, we can imagine that actual searching is one of the limitations of a secondary index. And really the reason why SASI in general was created, well, not the reason, I would say, actually. There are other reasons it was created, but SASI secondary index does offer some levels of text search versus over the traditional one. So that's one of the big obvious limitations of a secondary index. Now, I will mention that SASI is still in somewhat development. It's not widely used. So while there's text search capabilities in secondary indexes, probably not ready for prime time quite yet. But that is one of the limitations from a functionality standpoint. Now, this gets us into a little bit of a conversation about what is text search. Now, there are different flavors of that, and we'll get into some of those details. But let's say that searching is a limitation of a secondary index today.
Good. Okay. So secondary index is not equal to search. We need something that's a little bit more than just a basic secondary index or inverted index. So we need a distributed search solution. Let's talk about what that means. Like, what are the elements of distributed search, or what are the things that you have to consider in a distributed search solution?
Yeah, that's great. One of the first things that we can touch again on SASI on is the need to tokenize data in general, right? You've got your raw data stored in your data store, which is going to be DataStax DB for us. And then you've got search indexes that the functionality is able to perform on. To do things that, like if a word starts with letters or ends with letters, you've got to tokenize these things and create things that you can actually match them against. So that's a very clear functionality need that you would have to have on a write path of a system. So as data is coming in, you're able to break it up and assign it some metadata so that you can search on it. There's an aspect of text search that I wanted to get into, which is scoring. So the world that we come in from DSE Search, we have a score associated with documents or queries or rows, as we call them. This basically gives you the relevancy. How close is my result set to what I've searched for? That is something that has to be taken account, not just generating the score, but if you have a distributed system, there's going to be a positioning and a score associated with a document on the node, and then across the entire index, all of your data. So if I ask for the top 10 best results, you can easily get that for each node, but how do you really get that for the entire data set that you have? That's a great problem, a very standard problem to think about for distributed search. engines or systems, or if you're going to provide full text search in general.
Right, because it might be that the top 10 results are all on one node, but it's more likely that they're distributed across the various nodes. And then you have to, I don't know what, sort and talk to me about how that works.
Yeah, that's right. Exactly. It's a great point. A lot of users don't realize that there's some implicit sorting that happens. Now, we haven't touched on the technology we use to provide text search, but there is some implicit sorting with score that happens. So what has to happen, right? You've got to go first onto your search indexes to do the lookups that get the candidates, right? So you've got a distributed system. You've got data that's replicated. One of the improvements we've made with our pass on this, the scatter gather, if you will, the secondary indexes today will actually hit every node to be able to fulfill its query. We've taken the opportunity to utilize the replicas that we have in a cluster and reduce that scatter gather. So first of all, you've got to be able to look at the entire table's worth of data. So that means looking at all the partitions.
Right.
But as I just said, that doesn't mean looking at all the nodes. So if you've got replicas, and I think Dewey High mentioned this as well, 33% of the nodes will be taken or needed to look at the entire range of tables.
Okay.
So that's great.
And that's assuming that you can get a response from all of those and that there's not a node that's down, but right?
That sure is actually. That, oftentimes we're built on such a great distributed data store that we forget often a lot of times about the troubles of a distributed engine other systems would have to deal with. But you're absolutely right. Since we do have the system we do underneath the hood with replicas and availability functionality, we typically don't run into those problems. But absolutely, all of your replicas have to be up for you to be able to look at your index to say, who are my candidates? It's a very fundamental problem that I probably take for granted a little bit because of the fantastic data store that we've integrated with for our search indexes.
Okay.
But once you've looked at those search indexes and you've got what we call a candidate list, this is basically all the documents that match your query, you've actually got to go and retrieve them from the data store, because the way we've set things up is we don't store redundant data in your search indexes. Your data's held in your data store, our database. And then the search indexes are just the functionality to perform the scoring and the phrase stuff. So we do our search there, and then we'd have to go back to our data store to pull the actual raw data out. Now, this is the two-pass
problem,
yeah. Talking about. That's right. Now, that could be seen as a problem for performance, but again, knowing what we know and doing what we do, we have integrated things in the driver to actually tell DSE to say, hey, I'm not so worried about the true relevancy score. I actually just want to get the data back. So go ahead and skip that second pass and retrieve the data while you're there, and don't worry about this merge sort process.
Nice. Okay. I was going to say, you've told us a little bit about some of the problems of distributed search in general, and then some little clues here about how we've kind of solved them in our product in DSE Search. But let's take a step back and talk about kind of big picture, like what are the big design elements that go into DataStax Enterprise Search, and how do we choose those?
That's a great point as well. So first, let me say that DataStax Enterprise Search, what it is, some folks viewers may not know, it is an integration of Apache Cassandra and Apache SOLR. That's the genesis of the product. Now, of course, today we were doing a lot to make that more of a seamless integration, really more of a native functionality. But so we do talk about SOLR and Lucene a good bit in our search conversations. And that's ultimately what it is. Now, there's a lot of benefits from that, as we just talked about, some functionality that comes with it. There's also a few drawbacks as well, such as there is another set of processes that are contending for some resources. The fact that we want to index data that comes in will add a little bit of work for our writes. And of course, if we are searching on search indexes to find data, we expect that data to exist in our data store as well. So while we manage a lot of that consistency between the index and the store, there is still these windows of where data is being indexed and inserted into one or the other that have to be compensated for. We talked a lot about the query functionality, so we talked about scoring as well. These two pieces often we see these pieces a lot in different use cases, right? Going from, as we started the conversation, from indexes to kind of where we just talked about SOLR being more of a full text search engine. What we've also seen from a use case perspective in our users is a wide array of requirements for search. And what I mean by that is a company that's selling products online will be a lot more in line with what SOLR does out of the box, and they will more than likely utilize the scoring algorithm to rank things, and they probably even want to know what the real top 10 results are of product queries. For, let's say, a fraud detection use case where we're looking for some conditions, if this and that or this, we really don't care so much what order these results fall in. We just want to be able to find them or get them back in our result set. So a lot of those use cases can be called search, as they can be prefix or postfix kind of matching. But underneath the hood, there really is a big difference in what we're talking about. So when you hear full text search, it's going to be very important to understand what your use case is and what functionality is being offered. If we look at SASI again, it does offer full text search, but it does not offer the scoring mechanism. And sorting, like I talked about, there's a lot of implicit sorting that goes on. This typically is done with the scores, but the same mechanism that allows you to sort on score actually also allows you to sort on arbitrary columns that are not part of your primary key potentially, the way Cassandra will enforce. So you can sort on these fields. SASI does not have that right now, and we're not saying that's a problem. We're just going back to again, different use cases will need different levels of effort from search or different functionalities of search. And of course, the more you get from the functionality, the more you kind of pay for, at least with resources or some latency. But there is some cost associated with the more you get.
That's really good. I really like how you put that. It's basically, understand the tools, understand the capabilities of each of the options that you have so that you can really select and apply the right solution for the right problem.
Thank you.
That's awesome.
That's actually also something we're trying to make more seamless and automatic for our users, actually. One of the questions you will often field as a former field solution architect, you often get questions of when should I use a secondary index, or when should I use SASI, when should I use a materialized view, when should I just index it by SOLR, when should I use Spark? The list can go on. And these are all
I have that
valuable.
Question. Yeah.
Did you? You had that question.
Yeah.
There you go. So, one of the things I like to do is I draw out this graph of query flexibility to query performance, and all these items get listed on the spectrum. And as you move away from pure SQL and move towards Spark, you get query flexibility, but you also impose latency there. So one of the things we hope to do, at least for the search use cases initially, is to kind of do that due diligence for you. If it can be satisfied with this mechanism for the best price, we're going to do that. If you truly need to go down this route and it's going to cost a little more, we're going to do that for you as well. So a little bit hinting at a query planner and some query optimizations to go into our SQL, our native protocol here.
That's amazing. So that would be awesome. The less that we as developers maybe have to think about choosing between various options, the more that we can get some guidance or assistance on, if all we have to really think about is a sliding bar, I guess, in terms of query flexibility versus latency. That's the trade-off that we're making. That's going to be an awesome solution.
I'm very glad to hear that. And that also kind of recognizes the usage and value of customers who have not just invested in DSE Search for the functionality, but who invested in DSE Search as, again, a basic query engine. There was a lot of usage of this when I first joined the company, and we probably tried to fight this behavior a little bit because of, let's say, the product wasn't just where it needs to be to support this usage. Today, of course, it's far easier to embrace and support this usage, as well as there's a lot of validity to it than to try to fight this behavior. So
right.
That's the other reason for why we are not only integrating SQL search-enabled SQL, but also this optimization we just talked about is to reduce that complexity of using it, as well as kind of recognizing that there are different levels of search required for our use cases and offering the best flavor for that, and not just making everybody go the search engine route for some basic things.
Right.
As we've seen.
I want to come back to one of the design choices that you made that we kind of skipped over pretty quickly, but you mentioned that we picked SOLR as a key component of the search solution. So obviously that's not the only search engine that's out there that's available. How did you arrive at that over, say, like ElasticSearch or something like that? That's right.
It's not only not the only one available, but it's also not the most popular today anymore because of ElasticSearch, who's done a fantastic job with some of their choices they've made with their product. So the answer is actually very simple. ElasticSearch was not much of a product, if any bit of a product at the time where we were building our product. It was we'd have to go back to see what was available, but it was definitely a point version of something, and it just wasn't what it is today. There's been a very clear explosion of popularity with ES over the last few years, and it just wasn't there. What I am happy to say, though, is one of the other questions I get is, well, are you going to switch? And to that I say, well, no. What we're going to do is actually continue to tailor the product for our users and our use cases. What's going to end up looking like is going to be less of a SOLR integration and more of our Lucene implementation. So subtle words there, but it is a big difference as far as a lot of things go. Complexity, how the system behaves, the resources that get utilized, consistency problems, APIs. Let's talk there for a second. We've got
that's what it comes down to. Yeah,
that's what it comes down to. A lot of times, you've got this HTTP API and you've got CQL, and everybody would rather be on CQL if their functionality was supported. There's really not a lot of argument there. So at the very least, that's a big aspect of it. And ES is HTTP based as well, and while their query specific language is very popular, it's just not going to cut it for us when it comes to as the things you mentioned earlier, the cluster value, the cluster awareness value that you get with CQL. What node is up? What node is down? Which DC am I in? The health scores. We actually have put in indexing health scores for your search, so you know to ignore a replica if it's indexing and go toward a freshly indexed one. So there's just so many benefits of that, and even if we did have Elasticsearch today, we would be going down the same path of obfuscating that from users and collapsing functionality back into the platform, the native functionality of it.
Nice. Okay, so that's a really good explanation of what are those design challenges, and I like how you talked about some of the solutions under the hood to kind of do some recovery, knowing when a search index is out of date, and maybe that you want to route a request a little bit around that while you're waiting to get that updated. This is good stuff. Cool. You've also told me a little bit about the future of DSE Search, but I want to hear more. Like, what can you tell us about where this is headed?
Oh, that's exciting. That obviously is very near and dear to my heart, as it's my job for the most part. And a lot of it is exactly what we talked about. It's in one statement, it's less of an integration and more of native functionality. So the API is a big one for all of us here at DataStax. We want all of the functionality that our users are using to be inside of CQL, and for everybody to be using CQL for their workload.
Oh, that's a big deal.
The query is.
So like right now, the SOLR syntax seems to come through in those CQL queries. Are you saying that might go away, or what does that look like?
No, exactly right. We our first attempt, and thank you for bringing that up. I can give a little history there. So our first attempt at this integration was, again, an integration where we have a pass-through column that basically will take raw SOLR syntax and do your search for you. And it sounds great, and it is great, but the realization is that, hey, SOLR syntax is actually not all that commonly known. One of my favorite examples is showing how to do a range query with it, and it's very different.
Right.
Dare I say, a little silly. So So that's yet another API or language, or at the very least syntax to deal with. So in DSE 6.0, you will actually see search-enabled CQL, which is going to be pure CQL that can be executed on top of your search indexes, where we will support the like operator, which is, today there's not really much that gives you that functionality other than the SASI, and we talked about how that's kind of not ready for prime time. So DSE 6.0 users will actually be able to use the like command. And that's just the beginning of where we're going. If you look at the iterations of examples, none of them look like SOLR syntax. They all look like pure SQL or even SQL-ish type queries. And we've been told, and I'm sure, that is going to be a lot more comfortable for our users than the SOLR aspect of things.
Awesome. Yeah, I think API improvements is a great thing to make that developer experience just that much better. And I'm excited about the like keyword. Maybe once that drops, we can have you back on to kind of talk us through some of how that works. What do you say?
Oh, that would be great. I'd love to talk that off and show that off. And even today, we've already migrated all of the index operations, the admin, to CQL. So you can script creating your tables and creating your text analysis chains and your search indexes. All that stuff can be done in CQL today already, and you can do everything you need to do there. And then I will bring up for the SOLR Power users, who we certainly have a few of them in house. We're not gonna forget you guys. So pure SOLR syntax will certainly find a way to be passed through CQL, even with some of these new changes. So it'll just be a cleaner way of doing it. Not as much transposing the syntax and things like that. So very excited about that enhancement coming out for 6.0, and that's, like I said, actually just the beginning of the functionality. We've chosen to tackle the low-hanging fruit for some of the more database indexing use cases, but be on the lookout for geospatial filtering and, of course, the aggregation API as well, and score queries. We haven't tackled the scores yet for CQL, so the next revision guaranteed to be even more exciting.
Oh my goodness! Wow, you just dropped a bunch of stuff there on me that is super exciting, and as a developer and architect, I'm like, oh yes, I can think of those times where I really needed a geospatial query, and I couldn't figure out how to do that on top of Cassandra because of range queries and all these sorts of things. So lots of exciting stuff for us to talk about, and not enough time. Cool. I want to thank you so much, Nick, for coming on the Distributed Data Show and sharing with us.
My pleasure. Thank you so much for having me.
All right. Well, this is just a promise of future episodes on search, and thanks for listening. We'll see you next time.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel, or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.